Unit 3, Worksheet 4, Interpreting Graphs of Accelerated Motion. So right now we're going to look at object alpha, which is not actually going to be something that was printed out on this worksheet, but it's a variation of object A. Object A, we had the exact same graph shape, where it was this curve-like function, but object A was a position versus time graph. What we have right here is going to be a velocity versus time graph. We have these same questions, those four parts. Part A, where is the object above moving most slowly? Part B, between which points is the object speeding up? Part C, between which points is the object slowing down? Part D, where on the graph above is the object changing direction? And for each of these four parts, we need to answer, how do we know? Now, whereas on a position versus time graph, we need to look at the slope of that graph in order to figure out the velocity, which is the speed and the direction an object is going. For a velocity versus time graph, in order to figure out a velocity, all we need to do is to look at the graph itself in order to figure out where it's going to be going the fastest, or rather where it's going to be going the slowest. So on a velocity time graph, the time axis would be an indication of where the zero velocity is going to be. Everything above the time axis is positive. Everything below the time axis is negative. The further away you get from the time axis, or that velocity of zero, the faster you are going. So at point B, this right here is the absolute fastest the object is going to go. At point F, this is the absolute fastest the object is going to go. We have two parts of this where it's going to be fastest. Now, if we were comparing the velocities, B would have a greater velocity because it would be a positive number. F would be a lower velocity because it would be a negative number. But the sign doesn't really tell us the size of the number. It tells us the direction. So the fact that B is a positive velocity means it's fastest in the positive direction. F is fast, probably just as fast as B because it looks like they're the same distance away from the time axis. But because it's a negative velocity means it's fastest, but it's going in the negative direction. We can't look at these extreme points to say where it's going to be going the slowest because honestly, those are the biggest speeds that we have, the greatest velocities in the positive direction and the greatest velocity in the negative direction. Rather, the slowest speed, or the slowest velocity, where it's going the most slow, is going to be when the velocity is equal to 0 meters per second, which occurs at D. So where on the graph above is the object going most slowly? D. It is the only point that we know on the graph where the velocity is 0. The only other point that we could argue would have a velocity of 0 is at a time of 0 seconds. But because we don't have a point there based on this function, we're not going to use that as our answer. Between which points is the object speeding up? Previously, we had to look to see where the slope was getting steeper and steeper and steeper on a position time graph in order to answer that question. But for here, all we need to do is to see where on the graph is it getting further away from the time axis or a velocity of 0. That occurs in the entirety of the region from the origin up to point B. That is where it is speeding up because the velocity is getting bigger and bigger and bigger. It's really the start to point B, but once again, I'm just going to go between which points, so A to B. There's another region of the graph where it's speeding up, and that is from D to F. Here, the number is getting more and more negative, but the number itself is getting bigger and bigger and bigger, which implies that this object is moving faster and faster and faster. So those are the two regions of the graph where this object is speeding up. Now, where is it slowing down? It is slowing down at any point where the line is getting closer and closer and closer to a velocity of 0. That is from B to D, where it is slowing down. That also occurs from F to G, and then all the way left on that function. So, where it's slowing down, B to D, because it's getting closer to a velocity of 0, and from F to G for the same region. Now this last part, where on the graph above is the object changing direction? How do you know? Last time we were able to answer that by looking at the minimum and maximum points on our position time graph and seeing where the position stopped increasing and started decreasing, and then vice versa. We had 2 points on object A. But for object alpha, we need to see where it changes direction by looking at the sign of the velocity, because the sign of velocity tells us direction. A positive velocity means that the object is traveling in the positive direction. A negative velocity means it's traveling in the negative direction. So where this object changes direction is where the velocity changes from positive to negative, or negative to positive. And that only occurs at point D, where we have a velocity of 0. Because the instant before the velocity was 0, it was some positive velocity. The instant after, it was some negative velocity. So the sign of the velocity changed, so that means the object would have changed direction.